Hello, we are here for one more lesson of this T-FlexCam training course, and the topic for today will be the 3D milling, and in this particular case the part 3 of this big topic. I have one part here that I will use to create now some toolpaths and to play a little with them, so that we can see the finishing theme inside boundary 3D milling. So let us go to the boundary 3D milling. When we choose the icon, we get, again, you've seen already this regarding rough milling in the previous lesson. So today we are going to see the fine milling or finish milling, as you want to call it. So the idea it is, again, first choose the part to work. So this part, select a tool file, and inside select a tool. So I will work in these examples with this spherical tool, which it is a 20 mm diameter. All of these parameters, you know them already, so feed rates, allowance, spindle rotations, and a number of spindle RPMs. Then we have the pass types, and we have a couple of different pass types. Starting first with the zigzag. Increment, I will use, instead of a crest height, I will use a step of passes. I will use, for example, 3, and I will use the precision a little bigger so that it can take a little less time. So simply tell the system to calculate the program, and you get this nice toolpath. Okay, this is something that we can work with in terms of the finishing toolpaths. So if I edit this program now, and I will change this a little, I will say allowance a little more so that these paths in this more flat area are visible. So I will say this 0.5, and the intention is to be a little bigger than the precision. Let us calculate this again. So they should be above. Okay, as you can see, they are above now. So this is one possibility. Another possibility is to do it with constant crest height, and I can say crest height, for example, let us say a little less. Okay, and as you can see now, what is important is the crest height, and in these more vertical areas the pass reduces, but the idea now is the crest height with the same value always. We can, in this particular case, we get this result here, and I don't want to get it, and the way to turn around this is to choose boundary allowance. I would say, for example, -10. I think it would be enough, and okay, it limits the paths outside. We can choose still another type of program, so loop is not very interesting, but we can choose from these two types also, spiral and zigzag. So for example, the spiral, it's not very visible in this particular case. I will choose the zigzag, but the spiral, it will have the same purpose. I will choose, for example, 1 mil, and I will take the boundary allowance out and say OK. And now the expectation is to combine I hope it is visible. Okay, perfect. As you can see, let me try to show you. In these more flat areas, the idea it is to change from a vertical toolpath type and to work this in a different mode, so that these vertical or more, in this particular case, more flat areas are also finished properly. We can try to reduce the step of passes. I will abuse a little, so I will say 5. Let me try to, okay, let's try to simulate this one, and let us hope that it does not take too long to simulate. So as you can see, doing the Z-cut toolpath, okay, let us wait a little. It takes a little more time in these places. And in the final part, it should change the behavior in terms of movement. So almost ending. Okay, the final part. I'm not sure if I've done the circular interpolation, and probably that is why it is taking a little longer to reach the level that we want to see. Anyway, let us wait a little more. Okay, and now, as you can see, is cleaning the other areas in a zigzag mode. And if you see the options, we could do it also in spiral, even knowing that in spiral it's not so visible, the difference from the tool types. So these are different modes, but the interesting part it is, first, we can limit the place of program by applying, for example, and I will do a very simple solid. If we apply a solid somewhere, okay, I will not have an extra care about the position. For sure, it could be better position, but for the example, it is enough. If I do now another toolpath and choosing the solid, okay, choosing the second body, you remember the roughing, and if I do now the same stuff, so choosing not this one but the number 3, the 0.5, the same parameters, no problem, and a little higher, and I will choose my box in terms of parameters, the transparency, and as you can see, I'm not especially worried about the parameters, but as you can see, it has calculated only inside this box. So it's another way to work also in terms of limitation for the area that we want to work. Now, and going again for the program number 1, turn this out and visible this one. I will use the same type of toolpath because we are still in finishing. I will not change any of these parameters, everything is the same, but if I use, and I can make a zigzag, I can create, for example, 3, so that it does not take too much time, and I will change the vector and say now, instead of through Z, through X, and simply do the OK. Not correct, it's recognizing the same. Let us clean this guy here so that we are sure that it's not creating any problems. And okay, the part it is done. Vector 0, and going again to see if it is correct or not. Now, okay, now it is perfect. So you see, with the same tool type, with the same toolpath type, we create a program now that we usually call as a copy, and with the exact same parameters, just changing the vector where the program it is working. And we can do another thing, because usually this type of programs, people like to work with it instead of following one X. They use to combine the X and the Y, doing it at 45 degrees. And that can be done easily, maintaining one of the vectors, the X or the Y, and going to Z and saying 45. And if I do this in 45 or other value, it doesn't matter, you'll have this kind of toolpath also. So it is a very nice way to work with this. In terms of finishing, we've seen already the limitation, the type of toolpath, the combination with these guys here. In terms of the zigzag, the possibility to work in constant z-axis, or like this copy mode. These are directions, you know them already. The boundary elements, we've seen also this in terms of limiting initially the area, but we can do this also with the body. Circle interpolation, you know it already, and the precision that you are working with. And changing the tool vector, because we can work, as we've seen also for one of the previous lessons, we can index the axis, and not working only under the 3 standard axis mode, but we can rotate angles with this purpose. So and we can see, doing a simulation, we can see that the tool is on the correct position, okay, as you can see. So this opens to you a couple of more different modes, and when we speak in finishing, it's not only one more tool path type. So I hope these examples were clear, and again, as we say always, any questions or any help you may need, so send us a contact through the usual channels.